movement types and slap them on things. So excellent. Let's go ahead and save that. Make sure that we get all of our data set into that thing, and let's go ahead and start using it in our actual thing. Okay, and the reason I know so much about celiac disease is because celiac disease is a genetic thing, and my family, some of us are celiac, and it can cause some pretty significant problems for things you wouldn't expect. So, and also you have to like totally change your diet. Like, if you find out that you have celiac disease, you have to change everything about how you eat. And this whole like gluten-free craze that has swept up everybody really sucks, because gluten-free and like gluten-free for reals are very different, and only trace amounts of gluten can really screw somebody up with celiac for like a week. And so there, all this like gluten-free crap really actually causes problem for people who have legitimate problems with gluten, because a lot of the gluten-free stuff is not really gluten-free. It's like quote-unquote gluten-free. You know, it's like, we have it, but there's only a very small amount of gluten, or it was processed in the same facility as a whole bunch of donuts, so, there's just not much gluten. And then somebody who has celiac is just like, I hate all of you. I hope you die. I am slowly killing myself. Thank you for making my life hell. Alright, so this movement object is already on our entity. Let's make sure we can actually get it. It's like entity proxy data has the movement data on it, which is what we want. So the proxy actor has the entity data on it. Entity proxy actor turns into an entity actor. The entity actor. Do we have get movement data anywhere on this? If we've got our entity data right there. So I think we need to like add a thing to the thing so that we can call the thing from another thing and get what we need. That makes sense, right? Why don't we do that? So we're going to call get movement data. Or we're going to create the function get movement data on our entity actors so we can grab everything we need. Bodies are good at keeping themselves alive until they're not, yeah. And then it just all falls apart. The new Twitch layout is like all sorts of screwed up. Let me take a look. Well, Twitch won't even load for me, so that's how it goes. But yeah, the cancer. Like our when I was working at Amazon and we had, we used all the Twitch stuff. They would change crap all the time. That was just, and they wouldn't tell anybody about it. Like one of the times they changed their login so that basically it had this like login with Facebook option that they just stuck onto the page, onto like the front login screen. And they just put it there, and it did a whole bunch of crazy crap. Like, it was not well thought out. And as soon as like people started clicking on it, like it would crash their page and all that stuff. And all the people we were using at Amazon for like logging into our games was using the Twitch login. So all of a sudden, like people would click login with Twitch and just like they couldn't log into their game ever. It was just white screen. They're trying to log in. It's like, what? And I think we need to get a reference to the movement data, or do we want to get the actual like pointer to the movement data? I think we want to get a reference. So let's actually do that. So we're going to return m entity data dot something. And then like a couple hours later, like, and by hours I mean like days, they actually took out the login with Facebook button from their page entirely. And that's one of those things that like all of a sudden like you have it so your customers can log in with Facebook. Great, okay, cool. And then they just turn it off a day later. And it's just like, well, what the fuck? What about all the people who now wanted to log in with Facebook? It's one of those things that you're just like, come on, you don't screw with logins on pages. That's important. Like, what if all of a sudden you went to Amazon.com and you couldn't log in? There's going to be a lot of really pissed off people who need to log in to do things. I think a lot of disgruntled YouTubers are already flocking to Twitch. Yeah, there's probably some legal bullshit they gotta go through. So where is Dashkin entity data? Is Dashkin entity... It's not on the entity data, it's on something else. Because I think it's the proxy that has the actual movement data on it. So alright. The entity proxy has the actual movement data pointer on it. Okay, so we need this to be a pointer to get movement data, and it's going to be on the proxy. So we're going to need to have like we're going to have m entity movement equals proxy get movement data. So entity movement has to be a thing here, kind of like we've got this. It needs to be another u property. So it's going to be a movement object, not a movement object, a movement data object. So like this. So our entity actor, entity movement is going to have to be this null pointer here. So we're going to have to change this function here to just return entity movement. And we're going to need to add stuff to proxy data itself. Yeah, we're going to call the movement data pointer get movement data. And we're returning movement data. Yeah, YouTube's policies are not very favorable. I think Adam was going through some of that with some of his videos where, you know, the content monetization policies are just absolute garbage and the appeal process does not work at all. So you just get screwed because something, and it's just not worth your time to go through the process, because even if you go through it, like, what are you gonna do? Like, it's just not a good thing. Not a good thing. Oh, we already have a movement data function. Alright, good. We don't have to write another one. Yeah, copyright is such a strange issue. Because on one side you have content creators, on some sides you have big businesses, on other sides you have entire countries that just do not respect copyright. So that gives their businesses an advantage over ours because they can just steal whatever the hell they want and we have no legal recourse against that. But we can't steal what they have. It's a type of economic warfare in some ways. And I remember there was an argument in high school, like basically, easier just to take it down, fuck it, yeah. Where we were in social studies class, I believe it was freshman year, and we were talking about, sharing files and pirating and stuff like that. And our teacher was saying, she was making the case because a lot of some of those social studies, those teachers are really just trying to teach you concepts about things, like just get you to think about them and trying not to just force their opinions on you, at least the good ones. So the person, this teacher was saying, well, what about the content creators? You're literally just because people, of course, in high school or whatever back then, everybody was like, no, file sharing should be totally legal, and of course, she's like, you're trying to say theft is fine. And then, and then we're like, well, it's not really theft. We're taking a copy of something. And they're like, well, you're taking a copy of somebody's ideas. When they're selling those ideas, that is theft. And you're just saying that theft should be legal. And so there's a lot of sides to the issue. But it was just interesting thinking about that and being in class. And being like, well, yeah, I guess if I made something, I'd be kind of pissed off if somebody stole it. We had another really funny one there as well, where they're trying to teach us about communism and how communism worked under some different regimes, and they gave us all a bunch of marshmallows and toothpicks and were telling us to follow this spec to build a little marshmallow house. And of course, what happened was, the teacher would go around and take one of your marshmallows and eat it, and then you couldn't build your house because you didn't have freaking marshmallows. So some people were like trying to start trading with others, like, hey, I've got like an extra toothpick, can I trade you a toothpick for one of your extra marshmallows, and stuff like that. And the teacher would come around and, like, anytime she heard anybody trying to trade, she'd come in and be like, no, you can't do that. And of course people were trying to trade anyway, and was like trying to say, like, well, the free market in those situations kind of solves a lot of those small micro problems. It was really funny because my solution was she like ate half my marshmallows, so I just broke all my marshmallows into tiny little pieces to like stick the house together anyway. And it just came out looking like this awful looking, like horribly sound piece of shit. And she just like took it off, but she's like, see, this is what happens. You make awful crap. You don't have enough materials, you don't have enough nails, so you're just like, oh, screw it, we're just gonna make tenement buildings. And it was really funny. That was a fun class. Because we had another question, which high schoolers don't really get a lot of it, but one of the interesting things was we had a question of, if you put somebody in jail for, like, let's say meth users, you put some meth users in jail, and then in jail they get treatment for their problems and all that stuff, and then maybe they get free dental work, right? Like they get meth screws up your teeth, so they might get their teeth fixed. And people in class were like, well, why are we paying for them to fix? Why are we paying for convicts' teeth to be fixed? Like, That's a problem, right? Like, they're in jail. Screw them. You know, they made the choices to blow up their teeth. Why the hell should the state be paying for that? And, you know, as a bunch of dumb high schoolers do, you know, all of us missed the point. I was the only one in the class who had any problem with it. And my argument was, well, what if they, on the outside, could have gotten a job to pay for their own teeth, and because they were in jail, they couldn't pay for it. So, you know, maybe, you know, give them the benefit of the doubt and pay for it. But, you know, that's a weak freaking argument. It's stupid. I didn't understand the real thing. The real thing, of course, is why do you put people in jail? And if the concept of jail is to punish somebody, then, of course, we're not fixing your damn teeth. But if the concept of jail is to rehabilitate somebody and make them a contributing, positive member of society, then you fix the damn teeth, right? Like, they need to be back on their feet. These people need to be reformed, and part of that reformation is, you know, fixing the problems that happened when they were breaking the law, right? You know, that would be you screwed up your teeth, you screwed up your life. Let's get you, you know, back clean and sober, and make it so, you know, you can actually go eat some food. And none of us got that in high school. That was another interesting thing. Anyway, so we need to start grabbing our stuff here and get back to work. So we call set owner. We should be able to grab our stuff off of our actor. So we're going to do set movement data equals actor, get movement data. That's going to be on our movement object. Alright, so let's just do some basic stuff. Like, if our movement data equals null pointer, we're just going to return from our update loop. So we'll also log a warning here, because our movement data should never be null for an. Well, if it is, we can't do anything in the movement update, so we won't do anything. How about that? Sounds reasonable, I think. Something reasonable. So let's start going through here and discover physics state. So discover physics state is called on the first frame. So this is where we need to write a few things. We've got our spawn action. So basically we're going to want to switch off of our movement data. Don't we have it? What's it called? Entity movement? I'd like to just call it movement data. It's gonna be spawn action. Based on this, we need to do different things. So we're going to call place object on ground. I'm going to call don't do anything. So default on this will be nothing. Otherwise, smart place should do it. So this will be like place object smartly. This will be just like don't place the object anywhere. So we're gonna need to call cache physics object first. Then we're going to set our states and all these things based on what we're actually doing. Our movement type should be set to our movement type initially right here. So we should just do movement data, movement type. So we're going to need to do void u-dashkin movement object place object on ground, which we're going to say we're now on the ground and snap to floor. And we're also going to have to do like a bool able to place on floor. We'll set that to false. And we're just going to say if able to place on floor, then set our current state as being on the ground. Otherwise, we're just going to set ourselves to not being on the ground. So we're going to say, well, we're in the air. And we're also going to do a warn log here. We were unable to place an object onto the ground which is a problem. And place objects smartly, we really don't have anything yet for that. We'll have to write it. And leave ourselves a note. This function should try to attempt to place the object into the scene, but should do so without colliding with other objects. It will try to place the object as close as possible without overlapping other stuff. The birds are back, Hurricane? Oh no. So I think we're also going to start chunking some of these functions way down so we don't have to look at them anymore. Like update snap to floor is point, update snap to floor, yeah, those are fine. Set physics state and the rest, that should be down farther. Yeah, but like update in the air should definitely be above this like snap to floor stuff. Yeah, it should be up there. That way it's closer to the rest of these updates. Because what we want to do is I usually have like construction initialization code, then update code, and then specific update code, then just like nuts and bolts random crap at the bottom. That way, whenever you're in the file, if you're going too low, it's gonna go into stuff you don't really care about. Alright, we'll see what we got here. Keep rebuilding. Keep rebuilding. What is this? Calculate velocity has already been... Where's the first one? 670? Did we like... Copy pasted the entire damn thing, didn't we? Excellent. So now we can start doing the things. So, we're starting at the top and going down. So that was the first update. So basically in tick movement we're discovering our physics state. So we are now switching by our movement type, which has been set properly inside of our thing. And then we do like if we're on the wall. Yeah, so we're going to take out this on wall state entirely. It's another thing we have to do. Because it's not true, we're not on the wall anymore. Ever. So we can just remove it. So on ground. So our constant here is not going to be this g momentum change constant. It's going to be m movement data active change constant. So it's going to be active velocity change. And this one and look at that, we have our if statement has nothing in it. We're never using our passive. This is the passive one, so m movement data passive velocity change. It's one of the things I like about some other languages. You can't have a statement that doesn't do anything, which what we had right there was a statement that literally didn't do anything. Alright, so we need to have our slope to start landing z. So Slope to start sliding. Okay, slope to start sliding. Slidable slope value. That's the one right there. See our floor stick distance base. Floor stick distance dt and base. I think we also have a lot of copy pasta of this function, so why don't we just do it? Let's do calc floor stick distance. Just calc floor stick, and we'll pass in delta t, and that should be good enough. So this is going to be m movement data floor stick distance dt is 1 and floor stick distance base. So it's this plus delta t times floor stick distance dt. Just return that bad boy and we're done with you. And of course we're just going to throw this all the way down in some place that we'll never need to worry about again. Just the calculate velocity, calc floor stick. Yeah, so we just have to do that. Alright. Slope to start sliding z. That should be our slidable slope value. So we've got G gravity. I think gravity is on our stuff. We're gonna also have to start putting in stuff here to just turn off gravity and sliding, aren't we? See me the gravity force. The gravity force. So let's see. G max vertical speed times the sine of that, the wanted velocity is going to be all the way down. So we want our max vert. Gravity fails, gravity falls, yes. All of the gravity, all of the falls, all the time. So we should probably also be throwing these blocks in here for if gravity affects and all that crap. So we also need this mass effect calculation as well, which needs to come in here and do other things. But I think we're also going to need a little bit more. We're going to need to have overrides here, aren't we? So like we need to just go ahead and do this before we get too far. Like we need movement data, we need like movement data base, and we also need just movement data. One of them is going to be a real one of them is going to be a pointer. So we need basically movement data base is going to be this guy, and we're going to set like m movement data equals star movement database if m movement database does not equal null pointer. So we've got a copy of our movement data, and we also have like a base movement data, and then we should be able to call like reset on a value or something like. So we can temporarily override something, and then we can get like, what was the base value? The base value was 1,000. Okay. Did we just totally miss this thing? Yeah, we totally did. Passive constant velocity. Passive velocity change, active velocity change. The passive velocity constant is not... Okay, yeah. I'll just leave a note. No need to override. This is just a basic check. So if m movement data dot we've got like apply gravity, right? Gravity affects objects. So you can't slide on a slope if there's no gravity. I mean, supposedly you could, but you're not going to just slide. Well, Karakan, your question, gravity falls, but where to? Gravity, you're always falling, which is why you're always falling in space. Because you're always falling. Doesn't matter which direction you go, you're always going down. Alright, so slidable slope value. So again, this is going to be if m movement data dot so if gravity affects our object, then I want to do all this stuff. You're always going to. So floor stick distance again, we're just doing calc floor stick. Since we're no longer dealing with a pointer, we have to go change all these arrows to dots. So if you don't know much about programming, You may not know what the difference between a pointer and an object, like what a pointer is and what a variable is. That's just a data variable. And a pointer is, it's one of those programming concepts that if you don't understand, if it doesn't really gel with you, you're never going to be a real programmer in a lot of ways. Because if you don't get that concept, it's so ingrained in all that is programming and computers. And it's kind of a saying in a lot of programming schools. You'd be like, well, if you don't get pointers, you'll never be a good engineer. And some people just don't get pointers. And a pointer is, instead of like when you're talking about a CPU, right? You're talking about like, oh, the CPU is a 32-bit processor. This is a 64-bit processor. This one is, an 8-bit processor. This is 16. And those are the instruction widths and things like that. So you can have instructions. Like the CPU acts on instructions and all that stuff. So on a 64-bit processor, that's how big of a value that the CPU is going to be dealing with. So a pointer is, instead of having the actual value of an object, like the value of our health is 2. So you'd have, if you're adding together your numbers, you'd have like literally you pass to, like, if this box right here, this is the processor, and this is your program. So this is your program. And this is your CPU. Basically, your program is going to say, okay, so I've got this number 2 for my health, and I've got like the damage, which is like 1. So it's going to be like, okay, processor, I want you to like subtract, 2 minus 1. Go do that, and you can give the CPU or whatever, like, you say, okay, here's the number 2, and I want you to subtract 1 from it. So it's going to go do that operation, and it's going to be like, okay, so the answer was 1, because 2 minus 1 is 1. You'd be like, all right, thank you CPU for performing that operation for me. But with a pointer, basically, instead of saying, okay, I want you to have 2, I want you to subtract 2, we've got these things, like, this is our damage, and this is our health. Instead of saying, hey CPU, I want you to go, do 2 minus 1 for me or something, damage is actually just a pointer to like a damage object, and that thing is over here and it has a 1 in it, and this thing over here has a 2 in it. So instead of giving the CPU like all these 2, you're like, okay, I want you to take these 2 things, and you need to look up the values that these things point to, and then do an operation. So kind of the width of that character set. So like a 64-bit processor can address memory that is 64 bits in width. So like a 32-bit program can only actually have like 2 gigabytes of RAM, because 32 bits only can address 2 gigabytes of space. So that's a huge limitation for programs. 32-bit processors just, it's a problem. You can't, and of course modern day programs, that's an issue, because you've got 32 gigabytes of RAM, so that's a big deal. And 64 bits can span so much memory that it just doesn't even matter. So we're not going to run out of addressable memory space. But the pointer basically says it's got the address, so it's like saying, that's at 0xFF or whatever. Go fetch that. So it's basically, instead of saying the number is 2, it's basically saying the number is at this address. So it would be as if you, instead of having like like let's say you were trying to trade properties in Monopoly with each other, and to trade a property from one person to the other, you literally had to like pick up the property and like hand it to the person. You'd be like, okay, here you go. I'm gonna pick up this pond and just give it to you physically. Which obviously that's not gonna work, right? You cannot like physically pick up a pond and just give it to somebody. And if you could, holy shit, like either that pond is ridiculously small and that's not a problem, or you are the size of a mountain and I am scared of you. So, like a good example would be like, the deed in Monopoly is a pointer. It's just like this is a representation and also an address to a place. You can own this now. So you just hand somebody a pointer, and that's really easy. Be like, you own this now. You own Park Place or whatever. Congratulations. It's not like you physically handed him all the cars and the building and steel and infrastructure and the dirt that is Park Place. You hand him the piece of paper that says Park Place. There you go. Now you understand pointers and you can all be programmers. Because it's obviously a lot easier for a program to shift around the memory addresses, like location, like your house is at this address. It's easier to just give that to somebody than to just give them the damn house, right? That'd be like, in order to mail somebody a letter, you have to get the house and to like put the house on top of the letter and give it to the postman and be like, hey, deliver this to the house. And he like, thanks dude. And then he'd put the letter in the mail slot of the house and just leave, and then look at you very oddly. But he probably would do it because if you could actually physically hand him a house, I think the mailman would just kind of overlook that you're an insane person and instead be thinking about getting back to his wife and kids. But I'm sure that's incredibly entertaining. Anyway, let's get back to actual work instead of talking about crap. Alright, so tiny float, calc floor stick, we got that. Alright, so that's looking good. Alright, what should we get? The analogy might be a bit winged. I don't know. It's like when you actually pass a variable on the stack in languages like C++, it actually copies the whole damn thing if you don't pass a pointer or a reference. So it literally hands them the house. And it can be a real pain in the ass, like if you accidentally leave off a little star or an ampersand on your variable and you don't realize you're passing a house instead of passing the address of the house. Your code could suck and you don't even realize it. Alright, so normal to collision, tiny float, perpendicular, attempt mantle, true. So again, we've got floor stick, so it's like calc floor stick, pass in that sub delta t. Again, with the calc floor stick. Is this correct? Move the sweep location and return delta t. That's probably fine. Return delta t. Okay, so we're good here. Yeah. Well, the thing is, it's still usable, right? Like, if you could if you physically moved the house and gave a house to somebody, and you had like when you're writing stuff in computer languages, you write an operation. So you would write a functional block of code that does something. So like maybe if you're writing functions to do things on a house, you would say like, paint the house red would maybe be a function. So you'd say like paint the house red, and then you'd give the house to the function, and it would paint the house that you passed it. So if you passed it an entire house, it would paint that house that you just gave it. And at the end of the function, it would clean up all the variables that it used. And if you just gave it a whole house, and it would take the house, it would paint the house, then it would destroy the house. So that's just what function would do. So you'd pass it in there. You'd have like maybe a yellow house, and then you'd pass in, paint house, and then house, and then red. It would gladly copy this house, so it makes an identical copy of the house you gave it over on this functional block of code. It would paint that house and then blow it up, and then return, and your original house is still there. It's still yellow. But if you gave it a pointer to a house, you're like, okay, here, paint the house at 123 Fake Street Avenue. It would, and you gave that, the function would say, okay, we'll go to this house and we'll paint it. But then it's done painting the house. It would return, and the house, the thing you gave it was the address. So maybe it's a piece of paper with the address on it. So it would just burn the piece of paper. It'd be like, all right, cool, no more piece of paper. Awesome. And it returns, and then your house is painted red. In programming terms, that situation makes perfect sense. In realistic terms, it's kind of not always the same. Be like, how can you identically clone a house? And how long does it take to do that? Well, computers are fast, right? They can clone houses pretty quickly. Alright, so update snap the floor, sweep one direction, velocity, mantle iterations, mantle stuff, collision channels, sweep one hits. Tiny float, our height times I. Get max mantle height. Get max mantle height needs to return our... We don't want a max mantle height anymore here. We want or a max mantle iterations. Do we have mantle? Yeah, we need another one here, which is mantle iterations. This is the max iterations for mantling to be run for. And we'll have to set that to something reasonable. Set it to 3.0 F. Get max mantle height, set max mantle height, get mantle iterations. We don't need those anymore. Same with mass effect and set mass effect. We don't need that at all. Temp traverse seam, now a temp mantle should instead get the movement data. Dot mantle height. Mantle iterations equals movement data. Do we need this thing? Or can we just do movement data dot mantle iterations? So mantle, horizontal traverse, any of those things that we need to worry too much about? No. Horizontal nudge? No. So calc for stick again, sub delta t. Well, theoretically that should be compiling, so let's double check it all before we continue. Alright, so that should not be a U property, that's just a thing that we have on ourselves. Max mantle height should actually be 20 by default. Alright. And acceleration and max velocity? Are we even using those? Mantle height 20. We don't even use max velocity is what it looks like. Yeah, so we're just max velocity just doesn't exist. Alright. So we're just removing a whole bunch of stuff that we do not need anymore. Yeah, like acceleration and mass effect, we don't need you. Max velocity is gone, acceleration is gone. We're just gonna get rid of move objects code here. It's all trash pretty much. So we're just gonna comment it out. I want to keep some of it around because it's got the stuff that I want to use for setting some animation state stuff. We're approaching hour 6 of working on stuff today. So I would expect another 2 hours at least that we're going on. It's only 5:30 in the morning. It's not even dark out. Well, I mean, it's still kind of dark out.